Hi, my name is Dmitry Kornilov. I'm from Oracle. I am JSON-B spec lead, and today I'll talk about what's new in the Java API for JSON binding. This is a copy of my JavaOne session I presented on Monday, 19th of September 2016. That session was not recorded, so I made this copy for people who is interested in JSON-B progress but couldn't attend my session on JavaOne. You've possibly seen this slide on every other presentation and must be remembering it very well. This is illegal stuff. It says that what I'm going to present now cannot be included in the final version of the product. So don't trust to what I'm saying. Don't trust me, trust no one. Agenda. I'll start with a short introduction to JSON-B. I'll talk about goals, justifications, and some other boring stuff. After that, we will go through JSR status and progress. I'll report what was done during the last year. After that, I'll give you some API overview. Here can be people who've never seen JSON-B API, it's mainly for them. After that, I'll talk about what's not done yet and has to be done next. In the next JSON-B version. So let's start with introduction. What is JSON binding? At first, it's a JSR. It has its number, JSR 367, and it's all about converting Java objects to and from JSON documents. There can be a bit of confusion about names. JSON-B can be referenced as JSON binding or as JSON-B or JSON-B in one word. All of these are the same. I prefer using JSON-B, but you are free to use whatever you like. Here you can see a Java class called customer. It has some properties. It can have some methods as well. We are making the instance of the class, initializing its properties and so on. After that, we are converting it to a JSON document, which may look like this. So the question is where JSON binding is here. And JSON binding is here. It's this arrow which defines the rules how Java object is converted to JSON document and how JSON document can be converted to a Java class. Another use case is JSON-B can be used in other frameworks in behind, so users don't see it. For example, in Jackson RS, currently it uses JAX-B to convert Java classes to XML. It can use JSON-B the same way to convert Java classes to JSON. Now let's talk about goals, how it's written in the spec. The main goal is to provide a standard binding layer. It means serialization and deserialization between Java objects and JSON documents. All RFC 17159 compatible JSON documents, to be precise. In order to do it, we should have been studied and surveyed existing JSON-related specifications to determine their relation to the binding standard we are going to make. One of these specifications is iJSON, for example. Next goal is to maintain consistency with JAX-B and other Java EE and SE APIs where appropriate. As you know, JAX-B is a framework which purpose is the same as JSON-B but for XML documents. It's bigger, it has more features than JSON-B, and the most important, it's older. Users already know how to work with it. This goal is about making our API similar to JAX-B API. Next goal is convention. It means that we need to provide good enough defaults to make binding work well without customizations. On the other hand, we need to provide rich customization abilities which would cover many corner cases and provide flexibility. This is what customization goal is about. It's not written here, but those two goals also include studying the features of binding frameworks which are currently on the market and selecting the most popular of them for inclusion in the standard. API has to be easy to use and should not require prior knowledge of JSON documents format and specification. And the last one, we need to integrate it with JSON-B and possibly with some other Java EE frameworks. I was talking about goals, and now I will talk about non-goals. Non-goals is what's out of the scope, what we are not planning to do. The first is preserving equivalence if round-trip conversion is used. If we take a JSON document, convert it to Java class, and after that convert it back to a JSON document, we don't guarantee that these two JSON documents will be the same. We recommend it, but we don't guarantee. JSON schema is out of scope for the specification. So if there are questions about why JSON schema is not supported, here is the answer. And the last non-goal is JEP 198 support and integration. This JEP is light JSON API support in Java 9. We are not supporting it, but it can be reconsidered in future specification revisions. Now let's talk about supported platforms. JSON-B supports Java EE 7 and targeted for inclusion in Java EE 8. And nothing blocks it from using it in Java SE 8. As you know, Oracle is coming out with some interesting proposals for the next version of Java EE. It's going to be targeted to the cloud, and JSON-B is going to be one of the core its parts. And here are a couple of slides about business justification. On this slide, I showed the result of their survey, which was done a couple of years ago, at the beginning of 2014, by Oracle, before start working on Java EE 8. And there was a question, which of these APIs do you think is important to be included into Java EE 8? There were these 6 APIs, and the JSON-B, as you see, was voted the most. Another data is very fresh. There was a joint survey of Gson and Java EE Guardians. The results were published last week. There was a question, how important is to straighten JSON support in Java EE? This is about JSON-B, what JSON-B is doing. And the result is that 61.5% of participants think that this is very important, and only 3.1% think this is not important at all. And there were 825 participants in total. So all of these indicates the interest of community in JSON binding, and basically indicates that community still thinks that this is very important. Okay, that's it about the JSR. Let's talk about the progress now. JSON-B is a JSR, so it has its page on GCP website. Here is the link. Use it to find the current JSR status anytime. I actually went to the website and took a screenshot of the progress last week, and you see it here. This progress shows the overall progress of the JSR since it was created back in 2014. The most interesting for us are these two rows, what was done actually last year. And I put it on the separate slide so you can see it better. At first, we published the public review on 25th of May this year. It was reviewed and passed the ballot on 26th of July. Reference implementation was started. Actually, on the previous JavaOne, I introduced that reference implementation started and showed the first commit. Now I'm saying that it's not finished, but all functionality is implemented. And the snapshot is published, so you can download it, test it, try to use it, and give us your feedback. TCK development is started. It's in very early stage now, but important that it actually started. Also, there are some little changed in the API since the early draft last year. At first, adapters now look more like Jackson-B adapters. Remember, we have a consistency goal, so it's all about it. To provide a low-level access to JSON-B generator and parser during serialization and deserialization processes, we introduced serializers and deserializers. Similar functionality exists in other binding frameworks. This is a fine-grained and very powerful way to tune your mapping. It's a little bit dangerous as well, because you have control on how JSON data is written. And JSON-B value annotation is removed because this functionality is covered by adapters. Also, as you possibly seen already, we have a new awesome logo. It's contributed by Carla De Bona. Here is her Twitter. Thanks, Carla. You may ask question, what is on the logo? At first it's Duke. We have a Java framework, so Duke must be there. Second, it's all about JSON. And the first association which comes to my head, then I'm thinking about Jason, is Jason from Friday's the 13th movie. Remember, there was a bad guy wearing a hockey mask and machete. So we put a similar mask on our Duke to associate him with Jason. Not that Jason, but JSON document format in our case. The last thing we needed to add is binding, so we decided to give him a binding robe. He looks a little bit aggressive, which reflects our intentions to make the best JSON binding framework on the market, but he is actually very kind behind the mask. We have one more significant contribution. It's our new stunning website. It's contributed by Jackson, Zairi, Mohadam. Thanks a lot, Jackson. The address is jason-b.net. Here is the link. It's hosted as a GitHub page as part of our new GitHub organization. It's called JSON-B. The link is here. There are two repositories for now, a mirror of our RI from Eclipse.org and this new website. You can clone the sources and submit your merge requests. The idea of this website is not only to be not only the RI homepage. It's more to make a front page for all JSON-B related information. It has links to the latest version of the spec, latest version of RI, small getting started guide, link to Java docs, and so on. We are planning to develop it more, add manuals, add a better getting started guide, and so on, and community can participate in it. So I'm calling to action. If you want to contribute, join our mailing list. Or contact me directly. Here is my email address. And here is what actually, in which area you can contribute. First of all, we need to test our RI on some real-life use cases. If you are working on some project and using some JSON binding framework like Jackson, Gson, Gson, whatever, it would be nice try replacing it with JSON-B array and share your experience with us. We need a response in this area. Another task is performance optimization. Currently, array is not optimized for performance. We need to compare array performance with performance of other frameworks on the same tasks, set up performance and comparison tests, and the best is to create a job on our CI server for this purpose. Some existing performance measurement frameworks can be used. And when it's done, we'll need to actually go through the code and optimize it for performance. And evangelism. I already said about our new website. If you wish to write a nice guide or a manual or samples or FAQ and contribute it there, will be appreciated. Blog articles are also welcome. We are planning to add links section on the website where we will publish links to JSON-B related blog articles. JCP has adopted JSR program. There were already some JSON-B activity there. I presented JSON-B on CZ Jack and Bentonville Jack meetings. FASO Jack published a sample project adopting JSON-B on GitHub. Here is the link. If you are a Jack member or a Jack leader and you want to adopt JSON-B and you want me to present JSON-B on your Jack meeting, I'll be happy to do it. I have a special presentation called JSON-B Introduction and Comparison with Other Frameworks, which is done especially for this kind of cases. And here is the summary page with all the links. So here is a link to our website, our GitHub home, our jcp.org page, and our specification project on java.net. Okay, and now let's take a short overview of the API. And we will start with default mapping. The first question comes is, what is default mapping? It's a set of rules used by JSON-B engine by default. By default means that the engine is created without any customizations, and there are no annotations defined on the classes we are processing. Remember, we have a goal especially for this use case, and there is another goal about easy to use. So basically, default mapping covers these two goals. Default engine is created as simple as calling a static create method of JSON builder class, and here is a supported scope. I'll go through all of this later, and now let's take a look what methods JSON-B engine has. And it has a variety of toJSON and fromJSON methods with different parameters. toJSON is used for serialization, fromJSON for deserialization. All methods actually through JSON-B exception. I omitted it in the samples to save space. Here is a list of all basic and specific types as it's defined in the spec. As you see, basic types are primitives, wrappers with corresponding primitives, and specific JDK types include big classes, URL, URI, and optionals. Dates, I put it into a table, 2 columns. Left column has all supported date types. There are types from Java util package and from Java time package. In the right column, I put a format used for conversion. Formats look different, but they have one thing in common. All of them are ISO formats. Another thing important to mention here that if time portion is not present, it's not serialized. We're not adding anything. Here are some samples. The first sample demonstrates using of JavaUtil class, and this is what it's serialized to. The second sample is the use case where we don't have a time portion, and see the resulting string doesn't have a time portion as well. Next samples are for Java time types. You see instant here, duration here, and period here, and what it gets serialized into. The format is used for serialization is actually that format, ISO format I showed on the previous slide. Arrays and collections. Nothing much to say here. You see on this slide all supported types. That's pretty much all collection classes. Yeah, so that's it. Nothing much to say here. JSON-B types. Okay, other frameworks usually support these types in plugins and extensions, or don't support them at all. But we are using JSON-B as a parser and have integration with it as a goal. So we support these types by default. All supported types are listed here. And here is a sample. And actually JSON object is quite convenient. It can be used in adapters. It's very easy to use, so it's good that we are supporting this kind of functionality. Now let's talk about classes. The specification strictly defines what kind of classes are supported, and we support public and protected nested and static nested classes, anonymous classes only for serialization. We support inheritance. It means that all fields of parent classes are processed when the child is processed. And default no-argument constructor is required for deserialization. Remember, we are talking about default mapping now. There is a way to customize it. Specification is also clear about what types of fields are supported and in which order fields are serialized. So final fields are serialized, but not deserialized. Static fields are skipped, transient fields are skipped, null fields are skipped. Again, this is by default and can be customizable. Now about fields order. Lexicographical order is used by default, means alphabetical. It can be customized as well. And parent class fields are serialized before child class fields. Let's have a short sample demonstrating it. So here we have a class called parent with two fields, parent B and parent A. I especially put it in this order to show that in this JSON document, this class gets serialized. Fields are sorted alphabetically, parent A, parent B. Imagine that we have another class with child, which extends parent, and it also has two fields, child B, child A. And here is how the resulting documents looks like. You see that JSON-B respects parents and puts parent class fields on top of the child class fields, and within each class fields are sorted alphabetically. Scope and field access strategy. This is all about which fields of the class are processed. It looks complicated. This is copied from the spec. I'll try to explain it using another words. So JSON-B respects getters and setters. If field has a getter, it's called on serialization, setter on deserialization. JSON-B also respects getter and setter visibility. Only public getters and setters are processed. If a method exists and not public, the field is skipped. After that, JSON-B respects field visibility. So if there are no getters setters defined, it looks at the field and looks at its visibility. If it's not public, field is skipped. And the last one, virtual field support. If there is a pair of getter and setter and no actually field is defined, JSON-B processes, so it's supported. I have a small sample demonstrating this. So you see that we have a class with fields which have self-descriptive names. And here is a JSON document this class is serialized to. Let's just go through it and explain why the fields are not serialized or serialized. So public final field gets serialized because we support final, and it's a public field, so everything is okay. But private final field is not serialized. It's because it's not because of final, it's because of private. We are not JSON-B respects visibility and processes only public fields, as I said before. Public static field, it's not serialized because it's static. Public with no getter is serialized because there are no getter setters and visibility is public, which is okay. Public with private getter, not serialized because JSON-B looks at the getters first, and the getter is private. It respects its visibility, field is skipped. Public null field is skipped because it's null. If a value is different, it would be there. Private with no getter, again, no getter is there, field visibility is private, not public, so it's skipped. Private with public getter, this is a standard Java bin thing. It has a getter, and getter is public, so it's okay, it gets serialized. And these two actually define virtual field called no field, and this pair is public, so field gets serialized. That's it about defaults. Now let's talk about how mapping can be customized. There are two types of configuration, compile time and runtime. Compile time is a set of annotations which can be placed on classes. And runtime has two methods, JSON-B config and JSON-B builder. JSON-B config is a class which holds all runtime configuration. It uses sort of a builder pattern for easiness. In order to create a customized JSON-B engine, we need to first create a JSON-B config class with all customizations we want to have, and pass it to with config method of JSON-B builder. And JSON-B builder will create a customized JSON-B engine. There is another method of JSON-B builder with provider, and it's used to specify a JSON-P parser other than default. On this slide, I summarized all customizations provided by JSON-B. Let's quickly go through all of this in details. And I will start with property names customization. This is a very common use case. When we have a property which is supposed to be serialized using different name. In this case, JSON-B property annotation can help. It can be placed on a field or a method or a parameter. The parameter is a special use case. It's about custom instantiation. I'll touch it later. And if annotation is present, JSON-B will use name specified in the annotation, not property or method name. This sample demonstrates it. So we have a customer class, and it has a field called first name, and we don't like first name. We would like it to be name. So we place an annotation on it, which defines another name. The sample below is doing actually the same, but annotation is placed on the getter. There is also a way to customize how names are constructed globally using a naming strategy. JSON-B supports 6 predefined strategies, or a custom one can be created. These strategies are listed here, and in brackets I even have samples how the name would look like if the strategy is used. Naming strategy specified at runtime using with property naming strategy method of JSON-B config class. Property order strategy is used to customize order how fields appear in the resulting JSON document. There are three options. Lexicographical, that's the default one. Any. It means no strategy. In most cases, the order will be the same as order of fields, how they appear in the class, but it's not guaranteed. This strategy can be used for performance reasons. So JSON-B doesn't need to sort the fields. So that's very little performance improvement. And reverse is an opposite to lexicographical. So it's from Z to A. There are two ways to specify property order. It's JSON-B property order annotation on the class, as it's shown in the sample here, or at runtime using with property order strategy method of JSON-B config class. Another common use case is ignoring properties. Sometimes we don't want to serialize all class properties. We need to ignore some of them. So let's take a look at the sample. It's a customer and it has a field salary, and we don't want to serialize this field. It can be achieved using JSON-B transient annotation on this field. If this annotation is on this field, JSON-B skips this field. When I was talking about default mapping, I described the default property visibility strategy with respect of getters, setters, visibility, and so on. It's complicated, you remember it. If it doesn't work for you, it's possible to customize it. You need to create a class implementing property visibility strategy interface and plug it in to JSON-B using JSON-B visibility annotation, as it's shown here. So in this case, for this class, we are using some other strategy, my strategy, and it can be something like serializing all the fields, for instance, even private fields. Alternatively, we can plug in the custom strategy using with property visibility strategy method of JSON-B config class. Null handling. Sometimes we do need to process null fields. Sometimes we don't need to process null fields. By default, null fields are skipped. But there is a way to change it, actually two ways. So JSON-B nullable annotation, and at runtime using with null values method of JSON-B config class. This sample demonstrates it. So first use case is we have our customer class, and name is actually null, but we in this case do need to serialize it. So we are annotating it with JSON-B nullable, let's say. And this use case, if we place this annotation on the class, it will just work the same for all class fields. Customer situation. This customization is designed for a use case when we don't have a default non-argument constructor. The class is created using a static factory method, as shown on the sample here, or it actually has a constructor, but it's not default one. It has some arguments. So basically, we are annotating that non-default constructor or a static factory method with JSON-B creator annotation. And it indicates that JSON-B framework has to use this class to create an instance. So let's take a look at the sample here. So we have an order class, and it has a field of type customer, and this customer is actually instantiated not the standard way. This JSON represents the order, and when it gets deserialized, when it comes to the point of creating a customer object, JSON-B framework analyzes the class, found that JSON-B creator annotation is there, and after that, it actually passed the parameters defined under the customer here to the method itself. And remember, when I was talking about JSON-B property annotation, I said that it can be also placed on a parameter. So here is the use case. So if parameters names for some reason don't match, we can customize it using JSON-B property. So basically, JSON-B calls that get from the B method, it passes there 562 as a parameter. Datetime format is very important use case. We have two simple annotations, JSON-B date format and JSON-B number format to customize it. Take a look at the sample. Default date and default number are serialized using default settings, and formatted date and formatted number are serialized using custom formats, and the format is specified in the annotation. There is also a way to specify default format at runtime using withDate format and withLocale method of JSON-B config class. If binary data is processed, it has to be encoded. JSON-B supports three types of binary encodings: byte, base64, and base64 URL. Encoding is specified as a part of runtime configuration using with binary data strategy method of JSON-B config class, as it's shown on this sample. So we are using here base64 as default. There was a goal about studying existing JSON-related specifications. One of them is iJSON. It's short from Internet JSON. It's a restricted profile of JSON which is used for internet communication. Here is the link. JSON-B supports it by default with these three exceptions. But it's actually possible to switch a full support mode using a with strict JSON method of JSON-B config class. Okay, next is adapters. Adapters is a very powerful feature for customizing binding process. It allows to define a converter or adapter which converts a class we don't know how to serialize to a class we do know how to serialize. It's inspired by JAX-B. JAX-B has a similar feature. Adapters are very simple. You don't need to read objects from tokenizers or readers. You just define a pure conversion logic. To make your own adapter, you just need to implement in your class JSON-B adapter interface. Look here, it has two methods: adapt to JSON and adapt from JSON. And after that, you need to plug it into JSON-B framework. It can be done two ways. Using JSON-B type adapter annotation on a field. So basically it's saying that when this field is processed, this adapter has to be used. Or alternatively, with adapters method can be used, and it accepts a list of adapter instances as it's shown here. And serializers and deserializers. We introduced it to provide a low-level access to JSON-P generator and parser during serialization and deserialization. Similar functionality exists in other binding frameworks. We introduced two interfaces, JSON-B serializer and JSON-B deserializer. They have only one method, serialize and deserialize, and see that actual JSON generator and JSON parser are passed there. So these are JSON-P classes. And when you implement these methods, you actually need to write JSON and read JSON. So it's low level. To plug in serializers and deserializers, it works similar way as for adapters. There is a compile time configuration using annotations like it's shown here. or alternatively at runtime, JSON-B config has with serializers method and with deserializers method, which accept a list of instances. Okay, I prepared a small JSON-B demo. I'm not going to demonstrate it now here, but you can always check my GitHub. It's there, and play with it. It demonstrates default mapping, adapters, serializers, and mapping of generic class. And I'm planning to present it on HackerGarten. I'm not going to talk about this because this is a copy of the presentation. So basically the idea is play with the demo on the HackerGarten, the JavaOne. So now let's talk about what's next, what's planned for the next version of JSON-B. Here are the three things. First of all, we need to integrate it with other Java EE frameworks like Jackson RS, possibly JPA. Another very requested feature is JSON pointer. Now it's a part of JSON-P 1.1, and we are planning to include it in JSON-B 1.1. And another requested feature is partial mapping. It's all about if we have a huge JSON document but only want to use a part of it, we need to have the ability to map a part of a bigger document to a Java class. Okay, this is how to meet. I will skip it. And special thanks. I would like to say thanks to Roman Grigoriadi. He is our lead engineer for the reference implementation. Carla De Bona for awesome logo. Ehsan Zari Mohadam for a stunning website. Reza Rahman for support. And all experts and users for participation. This is a summary slide about how to give us your feedback. Again, this feedback is very important to us. And at first, there is a survey. It's similar to what was done in 2014. Remember, I mentioned the results at the beginning, so there is a new survey. Please participate. You can send any comments or whatever to this email address. And here are some GCP-related links: HackerGarten, JSR Progress, and Adopted JSR program. Where to learn more on JavaOne? Here is a list of sessions related to Java EE. There are quite a few of them. If you are interested in how Java EE is progressing, please attend. That's it. Thanks a lot. If you have any question, you can always contact me. See you later.